Hi there. We are going straight to a correction to yesterday's exercise. Now, correction. Today's number one. Let's copy the diagram. Question A. And paste it here. The question actually says we should find the value of x in each of the diagrams. So here, you can look at this first triangle. In this triangle, in this right angle triangle, you can see that x is the hypotenuse and y and 5 are the other two sides. So x squared equals y squared plus 5 squared. And that means x squared equals y squared plus 5 squared. But I can find y squared in the second right angle triangle, which is this. I want to find y squared in that second right angle triangle. And it is in the second right angle triangle, 15 is the hypotenuse. So that means 15 squared equals y squared plus 9 squared. And that simply means y squared equals 15 squared minus 9 squared, which is 225 minus 81. 225 minus 81. And that's minus 80 is 145, and that's 144. So y squared is 144. Y squared is 144, and we can now put that in x squared. Therefore, x squared, which is y squared plus 5 squared, is the same as 144 plus 25. And that's 169, which means x is equal to the square root of 169, and that's 13. X is simply 13. Now to question B. Copy that and also paste it. Question B. Question B. There we go. We are finding x, so I want to find y squared first. This is a right angle triangle. Now, in this right angle triangle, we see that in the right angle triangle containing, in this right angle triangle, this one, with sides y, 12, and 13. 13 is the hypotenuse, so I'm going to say 13 squared is equal to y squared plus 12 squared. And that simply means y squared equals 13 squared minus 12 squared, which is 169 minus 144. And that is 25. So y squared is 25. Now, in the second right angle triangle, which is this, in this right angle triangle, we can see that y is the hypotenuse. Or we can see that y is the hypotenuse, and we actually want to find x. So we say hypotenuse squared, which is y squared, equals the sum of the squares of the two other sides, x squared plus 4 squared. And that means, this means x squared equals y squared minus 4 squared. And we already know y squared. That means 25 minus 4 squared, which is 16. And that's 9. x squared equals 9, and that simply means x equals square root of 9, which is 3. Now to the third, that's question C. Copying and pasting that to question C, and that is it. C. We want to find x. We look at this right angle triangle first. This one. You can see that in this right angle triangle, y is the hypotenuse. So that means y squared equals 9 squared plus 12 squared, which simply means 81 plus 144, and that's 225. That means y squared equals 225. Now in the second right angle triangle, which is this, you see that x is the hypotenuse. X is the hypotenuse, so you say x squared equals y squared plus 8 squared, where y squared is 225, and that means 225 plus 64, and that's 289. So that means x equals square root of 289. X equals square root of 289, which is 17. That means x equals 17. Now, let me erase all of the markings. Now to D, which is the last one. Find the value of x in this diagram, in this figure. Find the value of x here. This is question D. Yeah. Okay. All right. We can start by finding. We might need to find y squared and z squared here. Let's go from the right angle triangle containing y, which is this. From this right angle triangle, y squared, because y is hypotenuse, y squared is 1 squared plus 1 squared, and that's 1 plus 1, which is 2. Now we can use that value of y to find z squared. You look at this right angle triangle, this one, and that right angle triangle containing z. In that right angle triangle, z is the hypotenuse, so we say z squared equals y squared plus 1 squared. Z is the hypotenuse, and y and 1 are the remaining two sides. Y squared plus 1 squared, and that means 2 squared plus 1 squared, which is 4 plus 1, and that's 5. So we can now use that, or those values. We can now find x from this right angle triangle. I'm going to select a different ink from this right angle triangle, which has x squared as its hypotenuse and z and 1 as the other two sides. 1 and z are the other two sides, and x is the hypotenuse. So we say x squared. Of course, you know that the hypotenuse is the side facing the right angle, the side opposite the right angle. X squared equals z squared plus 1 squared, and z squared is 5. So that means 5 plus 1. Z squared is 5. Y squared plus 1 squared. Y squared plus 1 squared, that's 4 plus 1. That's 5. And that's 5 plus 1, which is 6. Therefore, x is the square root of 6. That's not an exact value, so we just write it as it is. X is the square root of 6. You can just leave it as square root of 6, or check the square root table if you like for that answer. And I need to be sure that's very correct. So let's see that very, very quickly and be sure that it is correct. Okay, let's go over that again. Let me check the site. 11y z 1x. And that's 1x. That's correct. Y squared is 1 squared plus 1 squared. That's 2. That's correct. Z squared is y squared plus 1 squared. Yeah, that's correct, which is, oh, sorry about that. Y squared is 2. Y squared is 2, so that's supposed to be 2. That's supposed to be 2 plus 1. Y squared is 2, and that will be 2 plus 1, and not 2 squared. So that's 3. That means z squared is 3. And then if we go to this triangle, which has x as its hypotenuse. Sorry about that mistake. If you now check this triangle which has x as its hypotenuse, x squared in that triangle, is going to be z squared plus 1 squared. And we know z squared already, which is 3, plus 1 squared, which is 1, and that means 4. So x is the square root of 4, and that's 2. So x equals 2 units. So x is simply 2. And that's it, very, very simply. It's always as simple as that. Once you can identify the hypotenuse, it will be easy to use the Pythagoras rule to find the length of the remaining one of the sides of a right angle triangle when the other two are given. The length of the remaining one of the sides of a right angle triangle when the other two are given. Now let's see some other questions having to do with Pythagoras' rule in real life. Let's see that. Find the length of the rectangular. Okay, let's take a few questions. Additional examples. This has to do with Pythagoras' rule in real life. Number 1, find let's say that find the length of the longest straight line which can be drawn on a rectangular chalkboard. on a rectangular chalkboard which measures 2.2 meters by 1.2 meters. 2.2 meters by 1.2 meters. Now let's go to a solution. Straight to the solution. Now let's have this as a rectangular chalkboard. If it measures 2.2 meters by 1.2 meters, that means the length is 2.2 and the breadth is 1.2. And the longest length which can be drawn on it is its diagonal. So let's call this a diagonal of a rectangular board. Let me name that X. So of course this is a right angle. So if we look at this, and this is also a right angle, it's all of the angles inside the rectangle are each right angle. So we can bring out this one of the right angle triangles, which is this. This is the longest length which can be drawn on it. This will also be 2.2 meters, and this remains 1.2 meters. This is a right angle, and that means x squared, which is the hypotenuse of a right angle triangle, is 2.2 squared plus 1.2 squared, and that's going to be, yes, x is the hypotenuse. Wow. 1.2 and 2.2 are the other two sides of a triangle. So that's going to be 4.84 plus 1.2 squared, which is 1.44. And that's going to be 1.44 plus 8 plus 4.84. 1.44 plus 4.84 is 6.28. Take your time to check and be sure that that's correct. So x is therefore the square root of 6.28. X is the square root of 6.28, which is x is the square root of 6.28, which I think is 2.5 meters. That's 2.5. And that's supposed to be that's 2.5 meters. So therefore the longest length, that's actually 2.505, and it's approximately 505. That's 2.506, which is approximately 2.5 meters. Therefore, the longest length which can be drawn on the rectangle, is 2.5 meters. Now let's take a second example. Let's take a second example. Let's take a second example. Yeah, a palm wine tapper. A palm wine tapper climbs. A palm wine tapper climbs to a point. Climbs to a point on a palm tree. On a palm tree 9 meters above the ground. 9 meters above the ground. That means 9 meters above the ground. He uses a ladder. He uses a ladder He uses a ladder 10 meters long, which is leaning against the wall, against the foot of the ladder. Against the foot of the palm tree, Calculate the distance of the foot of a ladder from the foot of the palm tree. From the foot of the palm tree. Now we go over the question in 1 second before we attempt it. A palm wine tapper climbs to a point on a palm tree 9 meters above the ground. That means the point where the palm wine tapper reaches on the tree is 9 meters above the ground level. He uses a ladder 10 meters long, which is leaning against the foot of the palm tree. He uses a ladder 10 meters long, which is leaning against the foot of the palm tree. Calculates the distance of the foot of the ladder from the foot of the palm tree. Yeah, that's clear, and that's very, very simple. Now to the solution. Let's have this as the height which the palm wine tapper reaches on the tree, and that height is 9 meters above the ground. So if this is the ground level, then from this point up is going to be 90. I think that can stand on this line. This is the ground level. The height which the palm wine tapper reaches on the tree is 9 meters above the ground level. So this is going to represent the ladder leaning against the foot of the tree. So let me call this top of tree, foot of tree, and Okay, that's the top of a tree, and then this is the foot of a tree, leaning against the palm tree, leaning against the palm tree. Okay, and this is the point on the ground where the ladder rests. I read that question again. Lean against again, which is leaning against. He uses a ladder 10 meters long, which is leaning against the palm tree, not against the foot of a palm tree, which is leaning against the palm tree. Against the palm tree. It leans against the palm tree. You can't lean against the foot of a palm tree, which is leaning against the palm tree. Which leans against the palm tree. Calculates the distance. Calculate the distance. I think I can rearrange. Calculate the distance. The Shumoba. Calculate the distance Calculate the distance of the foot of the ladder from the foot of the palm tree. Now, this is a question clearly. A palm wine tapper climbs to a point on a palm tree 9 meters above the ground. He uses a ladder 10 meters long, which is leaning against the palm tree. Calculate the distance of the foot of the ladder from the foot of the palm tree. So this is the palm tree, its top and its foot, and this is the point on the ground where the ladder. This is the point on the ground where the ladder. This is the point where the ladder is touching on the ground, and it leans against a palm tree this way, and that's shown by the line PT. So this is a right angle. This is a right angle, and the ladder is 10 meters long. So we want to find the distance of the foot of the ladder to the foot of the palm tree. P represents the foot of the ladder, and F represents the foot of the palm tree. So, of course, this is a right angle triangle, so we can use Pythagoras' rule using Pythagoras' rule. The hypotenuse squared, which is PT squared, is equal to the sum of the squares of the other two sides of the right angle triangle, and that's PF squared plus TF squared. Hypotenuse is 10, that means 10 squared equals PF squared plus TF is 9, and that means TF squared is 9 squared. And this simply means PF squared, which is the distance from the foot of the ladder to the foot of the tree, is going to be 10 squared minus 9 squared, and that's 100 minus 81, which is, that's supposed to be 100 minus 81, that's 19. So PF is therefore square root of 19. PF is therefore square root of 19, and that's going to be, that's 4.3589, which is approximately equal to 4.4 meters. Therefore, the distance of the foot of the ladder, from the foot of the tree, from the foot of the palm tree is 4.4 meters. And that's it, very, very, very simply. I hope you got that. There's going to be, yeah, I hope you got that. I'm sure you'll be able to answer questions on your own when you take your time to understand all of this. That's going to be it for today. Thank you very much and see you in the next. Bye bye.